we are looking at calculating the number of elements in a power set A. So how is this possible? How is that I'm able to calculate the number of elements in a power set? Well, whenever we talk about power set, it is dependent on what? It will be dependent on the elements in A, right? The set A itself. Is it not? If I'm talking about power set A, it is dependent on set A by default. Agree? Therefore, what can I conclude? The number of elements in a power set, it depends on elements in the set itself. Okay, so n of A, if it represents number of elements in a set A, if this is so, okay, then what do we have is, I'll take an example. If the number of elements in a set A is 10, say we have a set which is made up of 10 elements, then the power set will have, the number of elements in the power set would be 2 to the power of 10. Okay, so next possibility is something like this. I'll show you one more example. If the number of elements in set B is 4, the number of elements in power set B would be what? Yes, 2 to the power of 4. So basically, in general, so what is that we are looking at? In general, if I happen to see a set with n number of elements in it, the power set C, that particular set C, the power set of C, the number of elements in that would be what? Yes, 2 to the power of n. Okay, so I have mentioned in your concept map as well. See to that you guys make use of this. So if, oh yeah, before I conclude, let me kind of show you guys this. Say I have 2 elements in the set, right? So let's look at this. So the number of possible subsets are 1, that is the null set, then 1, 2 and 1, 2. So there are 4 of it. So you can see my program is able to generate the answer 4. So I increase it to 3. So my system is able to do that again. So we have 4 over here, 4, 8. So I'm able to generate 1, 2, 3, 4, 1, 2, 3, 4. So we have 8 as a number of possible subsets. Is correct, right? We have null 1, 2, 3, 1, 2, 1, 3, 2, 3 and 1, 2, 3. So here again my system is able to generate the answer 8. If I increase it to one more element, so it might be a bit tough to count in this way. Let me expand this. So we have 1, 2, 3, 4, right? There are 4 subsets, then again 4, then again 4, then again 4. So there are 16 possible subsets. So my system is able to generate that number again. How is this possible? Clearly these are nothing but powers of 2. So here my system is able to, in this 2 lines of code, my system is able to find the number of elements in the set A using len, okay, a keyword len. So then using that value, here we can see in this line the number of elements in the power set is given by 2 to the power of n. So this indicates 2 to the power of that particular value. And so end of it, we have the answer to be 2 to the power of n over here. Okay, so this is how you calculate the number of elements in a given set. A small note, say I have a set Y, which is nothing but a null set. Okay, then the power set of this set Y would have something like this, or something like this. They are one and the same, just that the symbols are different. So here the number of set in y is equal to 0. You guys agree? So the number of elements in the power set of y will be equal to 2 to the power of 0, which is nothing but 1. There are 0 elements in this power set. Sorry, not power set, sorry, in set y. The power set of that set will have 1 element, right? So you can see that everything comes together, the whole math and the concept comes together. So I want you guys to understand that this is the formula for the number of elements in a power set, and it agrees with null set as well. So that was the conclusion. Okay guys, so it's quite simple, and if you guys forget in time, you just have to revise this particular line. That's it. Okay, don't come back to the video and watch and all of that. It's a very simple concept.